The idea of this video is to look at a range of different algebraic problems at GCSE higher level. In some of the cases we'll be solving equations, in others we will simply be either factoring or simplifying algebraic expressions. So for example, this is an algebraic expression. An equation will be equal to some value. An expression is just a collection of algebraic terms. We're going to go through a few of these and look at some different techniques in which we can use to solve them and then go from there. The first one is a quadratic equation. It's set to 0 and it's in the form ax squared plus bx plus c is equal to 0. When we're solving a quadratic equation, the first thing that we want to try and see is, does this factor? If this will factor, we can solve it by factoring. So we need two numbers that multiply to give -8 and add to give -2. That's going to be plus 2 and minus 4. So in a set of brackets, I put x plus 2 and then x minus 4, and we set that equal to 0. That tells me that either x plus 2 is equal to 0 or x minus 4 is equal to 0. If x plus 2 is equal to 0, then x will be equal to minus 2. If x minus 4 is equal to 0, then x will be equal to 4. One of these, or both, have to equal 0. When we multiply anything by 0, we're going to end up with 0. So either this bracket equals 0 or this bracket equals 0. This time we've got another quadratic equation, but we don't have the c value. This one is written in the form ax squared plus bx plus c is equal to 0. And in this case, a is 1, b is minus 2, and c is minus 8. We don't have a c term here. So all we do is look for common factors, and the common factor is x. We take that outside a set of brackets, and it becomes x minus 4 is equal to 0. So again, either x is equal to 0 or x minus 4 is equal to 0. That gives me that x is 0 or x is equal to 4. Just think about this, x minus 4 is equal to 0. Quite clearly, all it's going to be is the opposite of this number. Okay, this one right here, this is just a basic linear equation, and there's lots of different approaches that you can do with this. If you're not comfortable with the negatives, the first step you can do is add 2x to both sides. So what we get is 4 is equal to 6 plus 2x. We would then subtract 6 from both sides, which would give me minus 2 is equal to 2x. And then we would simply divide by 2. Minus 1 is equal to x, or x is equal to minus 1. If you're confident with dealing with negatives, we can simply subtract 4 from both sides, so we'd have minus 2x is equal to now 2, and then divide both sides by minus 2, which would give us x is equal to 2 over minus 2, which of course is minus 1. That's a nice straightforward linear equation. No problems at all. All you're doing is solving for x. This one right here, okay, we've got 1 over 2x is equal to minus 2. We can simply multiply both sides by x and divide both sides by minus 2. So what I can do on this one is swap those places over. So I can write now 1 over 2x is equal to minus 2. Multiplying both sides by x, I'm going to have 1 over 2 is equal to minus 2x. And then dividing both sides by minus 2, I'll have 1 over 2 multiplied by minus 2 is equal to x. So we can see from there that x will be equal to 1 over minus 4, or minus 1/4. Again, if you're not confident, lots of different ways you can think about that. But essentially, we can simply swap the x's and the 2's over. There's no additional subtraction to worry about. Okay, let's go on to the next one. This is a quadratic equation. It's not in the form that we want. The form we want is ax squared plus bx plus c is equal to 0. All we need to do is subtract 12 from both sides. So we can rewrite this as now x squared plus 4x minus 12 is equal to 0. It's a quadratic, it's in the form ax squared plus bx plus c equals 0, so we look to factor. We want two numbers that multiply to give minus 12 and add to give positive 4. That looks like x plus 6 and then x minus 2. And that's equal to 0. Over time, you'll just get comfortable with spotting these. So either x plus 6 is equal to 0 or x minus 2 is equal to 0, leaving us with x is equal to minus 6 or x is equal to positive 2. And they're our two solutions. This one here is a quadratic, but it's already factored. You can see it's in the form that we've got here. So all we need to do is consider that 2x minus 1 is equal to 0 or x plus 3 is equal to 0. And just think, if 2x minus 1 is equal to 0, 2x is equal to 1, and dividing both sides by 2, x is equal to 1/2, or x is equal to minus 3. And that's fairly straightforward. If 2x minus 1 is equal to 0, x is going to be equal to positive half. If x plus 3 is equal to 0, then x is going to be minus 3. If it's already factored, don't do the crazy thing of expanding it back out and then trying to solve it. It's already done for you. Okay, this is now a linear equation with unknowns on both sides. The idea is to get the unknowns on one side together. All we do is reverse the order of operations. 4 minus 2x is equal to 5 plus 3x. So 4 minus 2x is equal to 5 plus 3x. I want to get x's on one side, numbers on the other. If I subtract 5 from both sides, I'm going to have now 4 minus 5 is minus 1, minus 2x is equal to 3x. I now want this on the other side, so I need to add 2x to both sides. So minus 1 is going to be 3x plus 2x, which is going to give me 5x. And then we simply divide now by 5. So x is going to be equal to minus 1/5. Don't be worried that it's come up at that. If you put it into a calculator, you'll quite clearly see you're going to get the answer that you want. So don't be worried that it's not what we call an integer, a whole number. That doesn't matter at all. This will be perfectly fine as your answer. And if you want, you can put it in decimal form as negative 0.2. But in terms of algebra, it's far better just to leave it as a fraction, in my opinion. Okay, let's now move on. Where have I got to? Just here. X over 2 is equal to 3x over 4. What we want to do is clear the fractions. If we multiply through by the lowest common multiple of 2 and 4, that will do it. The lowest common multiple of 2 and 4 is 4. So if I multiply both sides of the equation by 4, what I'm going to get is 4 lots of x over 2 is equal to 4 lots of 3x over 4. Quite clearly this is going to cancel, and I'm going to end up now with the following. I'm going to have on here 2x is going to be equal now to 3x. The 4's are going to cancel to give me 3x. This means that x can only have one value, and that must be equal to 0. There's no value where 2 lots of a number is equal to 3 lots of a number other than 0. And don't be scared of putting that in. It doesn't matter. X is going to be equal to 0. Okay? There's no other value that's going to work. Okay, x squared minus 25 is equal to 0. With this one, we've got two choices. We can either add the 25 to both sides, so we have x squared is equal to 25, and we can solve by taking the square root of both sides, and that's going to leave me x is going to be equal to, and remember this is plus or minus the square root of 25, which is going to be x is equal to plus or minus 5. Don't just put 5. If we think about the quadratic graph now, if you square a negative number, you get a positive value. So if we take now negative 5 and square it, and we take positive 5 and square, we're going to get 25. Therefore, the answer is a plus or minus. Another way of looking at this, we call this a difference of two squares. We could have written this as x plus 5 and then x minus 5 is equal to 0. By factoring it as a difference of two squares. That would certainly be less common in terms of if you were just asked to solve this, but it's always nice to appreciate the difference of squares. So for example, x squared minus 36, this would be x plus 6 and then x minus 6. So there we go, x is either equal to 5 or minus 5. Okay, completing a square. We're not solving here, we're simply completing a square. To complete the square, you take x and half the coefficient of the x term into a set of brackets. So what I'm going to have here is x minus half the coefficient of the x term, which is going to be minus 1. We square this, and then subtract away this number here squared, which is going to be minus 1 minus the original 12. So x minus 1 all squared minus 13. That is now in completed square form. So for example, if we were asked to complete the square on x squared plus 4x minus 3, we would take half the coefficient, so it would become x plus 2 all squared minus 4 minus the original 3, and this would give us x plus 2 all squared minus 7. We can use completing the square to solve quadratic equations, especially helpful if they don't factor. So let's consider now that this it's not going to, let's just say it's not going to factor, okay? So what we'll do now is set this equal to 0. And if we needed to solve this equation, we could do that by completing the square. So when we've completed the square, we end up with this scenario. So all we do now is add the 7 to both sides. X plus 2 all squared is equal to 7. We square root both sides. X plus 2 is equal to plus or minus the square root of 7, and then we subtract 2 from both sides. So x is equal to minus 2 plus or minus the square root of 7. And that's what we call in third form. And you would leave your answer like so. You can of course put it through a calculator, but that answer would be perfectly fine. The next one here, we have another quadratic equation. It's in the form ax squared plus bx plus c is equal to 0. So the first thing I say to myself is, does this factor? We want two numbers that multiply to give negative 8 and add to give positive 6. The answer is no. We've got two choices. We could complete the square, and if we did that, what we'd have is x plus 3 all squared. I've taken half the coefficient, subtract away 9, subtract away the 8, and that's going to be equal to 0. So x plus 3 all squared is equal to, adding these to the other side, 17. At this stage we take the square root, and we could say x plus 3 is equal to plus or minus the square root of 17, and then we would simply subtract 3 from both sides, and this would become x is equal to minus 3 plus or minus root 17. And if you wanted to find out the value to 1 or 2 decimal places, you could do that on a calculator. Alternatively, we could use the quadratic equation. The quadratic equation is minus b plus or minus the square root of b squared minus 4ac all over 2a. And that will give us now the value of x. This will be in the formula book of your exam. You don't have to remember it. If you want to, it will come in use later on in your studies, but for now, if you don't want to remember it, you don't have to. So let's look. This is a quadratic in the form ax squared plus bx plus c is equal to 0. So we can see that the a term is 1. The b term is going to be positive 6. Let's make that look like a b. Well, less like a 6 anyway. And the c is going to be minus 8. So all we would do now is put this in. So it would be minus 6 plus or minus the square root of 6 squared minus 4 times by a times by c, which is going to give us now the value here. And we're going to put that all over 2a, which is going to be 2 lots of 1. On a Casio, you can put this through as a quadratic equation. Fraction bar, and if you put in now minus, and all we'll do, we'll feed the values in. Here's your b, then we start with a plus, and then we got the square root of b squared, and I'm going to feed b in there, minus 4 lots of a times by c, all over 2 lots of a. So if you just feed in the numbers here, this is a quadratic equation. So we'll start with the beginning, and what we'll have now is 6, that's the value of b, then 6 again, and then all we'll do now is feed in a, which was 1, and then c, and be careful with this, kill a mistake, people just put 8. It's going to be minus 8. And that's all over 2 lots of a, which is going to be 1. And then this gives us now, as we can see from our work before, minus 3 plus root 17. And all we do to get the negative one is come back over and swap this over. And we can change that now to minus. And that will give us minus 3 minus root 17, which was that other solution. If you want a decimal answer, there's 1. All you do is hit your SD button, and then if you wanted a decimal answer, the other, which of course you could have done to begin with, let's delete that rather than pressing SD, and then we would get now the value there. So nice and straightforward using the quadratic equation. Okay, let's look at some others. Let's see if I can move this on. I've put some more. Here we are. Okay, this one here, 9x squared minus 64 is equal to 0. Another quadratic equation. Again, the general approach for this one would be to add now the 64 to both sides. So if we do that, what we're going to have now is 9x squared is equal to 64. Dividing both sides by 9, x squared is going to be equal to 64 over 9. And then we would square root both sides, and x would be equal to plus or minus the square root of 64 over 9. So x would be equal to plus or minus the square root of 64 is 8, the square root of 9 is 3. So there we go. If you wanted, you could see this as a difference of two squares. This is going to be now, what's that going to give us? 3x plus 8. And then we're going to have 3x minus 8 is equal to 0. So if you're asked to factor it as a difference of two squares, it is, because this is a square number, this is a square number, and that's a subtraction sign. So there we go, that's where we wind up. Okay, let's have a look at this one. Now this one will factor. It looks like it's going to factor anyway. I'm going to take a guess that it will. So a way that I like to factor these, and you don't have to, you can use a quadratic equation unless you're asked to factor it. The way we factor when the coefficient is greater than 1, the way I like to do it is 4 times by minus 3, which gives me minus 12. I'm now looking for two numbers that multiply to give minus 12 that add to give 1. And that's going to be plus 4 and minus 3. The way in which I like to do this, and mathematically it's not ideal, but I just simply write the following. So what we do is the following. We write 4x plus 4, and then we write now 4x minus 3, and we set that equal to 0. We check if any of these can be simplified, and they can do, and we can write this now as 4 the quantity x plus 1 multiplied by 4x minus 3. So either x plus 1 is equal to 0, so x would be equal to minus 1, or 4x minus 3 is equal to 0, and x would be equal to 3 over 4. So all I've done is factored it by multiplying the a term by the c term, finding the two numbers that give me now, so multiply to give minus 12, and add to give now positive 1, factor them, tidy this up. When we take this out, we can simply divide through by the 4, and we end up with these solutions. If you'd done that on a calculator using the quadratic equation, we would have had now minus b, which would have been minus 1, plus the square root of 1 squared, minus 4 times by a, and a is 4, times by c, which is going to give us minus 3, and we would have put all of this over 2a, which would have been 2 lots of 4. And this will give us now on here 3/4, which was one of my solutions, and then all I would do is swap this over now and make this a negative, and then we would have now the other solution of minus 1. So we could have used quadratic equation, or we could factor it. If you want some more on factoring, please check out my channel. I've done something as, look at the link here, there's something on factoring when the coefficient is greater than 1. Mathematically it's a bit dodgy, but it kind of works. Okay, let's look at another few of these. 4x minus 1 is equal to 3. Straightforward linear equation. We're simply adding 1 to both sides. So 4x minus 1 is equal to 3. Add 1 to both sides. 4x is equal to 4. Divide through by 4. X is equal to 1. Sometimes on higher papers you'll be asked to solve very basic equations. Don't get caught out by them. It's often the case that people think there must be more to it. There simply isn't. You add 1 and divide by 4. Okay, that one through a quadratic equation, This one simply divide by 3. Okay, let's look at this right here. Now, if we think about this one here, what we've got is 2x is equal to 8 over x. And these are the kind of ones that cause people problems. If we now multiply both sides by x and divide both sides by 2, what we have is x squared is equal to 8 over 2. So x squared is equal to 4. Square rooting both sides, x will be equal to plus or minus the square root of 4, which is 2. So x is positive 2 or x is negative 2. It's a quadratic equation. All we do is multiply through by x. 2x squared is equal to 8. Divide through by 2. X squared is equal to 4. And then solve from there. Okay, this one right here. 2x squared plus 5x is equal to 12. So let's go on to another page and do that one. Give ourselves some space. This is a quadratic equation. It's not in the form that we want it. So we'll rewrite this as 2x squared plus 5x minus 12 is equal to 0. This 2 looks like it's going to factor. And off the top of my head, I'll factor it first and then come back to it. What we're going to have then is 2x minus 3, and then we're going to have x plus 4. That looks like it's going to work. 2x squared, and then we're going to have plus 8x minus 3x minus 12. The way I thought about factoring this now is 2 times by minus 12 is minus 24. We need two numbers that multiply to give minus 24 that add to give 5. And they're going to be plus 8 and minus 3. So if we wanted to factor this, again, using the method, I'm not suggesting it's mathematically rigorous as such, but it kind of works. All we would do here is 2x plus 8, and then we'd have 2x minus 3 is equal to 0. I can see I can take a common factor of 2 out to leave me x plus 4, and then 2x minus 3 is equal to 0. So my factors now are 2x minus 3 and x plus 4. So if 2x minus 3 is equal to 0, then x will be equal to 3 over 2. If x plus 4 is equal to 0, x would be equal to minus 4. Just consider 2x minus 3 is equal to 0, 2x is equal to 3, and then x is equal to 3 over 2. It's a basic linear equation. If you can't spot and factor that, which is quite a high skill at GCSE, whack it through the quadratic equation. If you wanted to complete the square, you could do. When you complete the square, though, we need to ensure that the term in x squared is is a single value. So the number in front is 1, the coefficient is 1. So if you wanted to do this and you wanted to now complete the square, you could do the following. You could write this as 2, and then we've got x squared plus 5 over 2, and then we'll have 5 over 2x minus 6 is equal to 0. And then you can complete the square on this. So if you wanted to complete the square to solve, we can ignore the 2 as we divide both sides by it. We could write this now as x plus half the coefficient, which is 5 over 4. We would square this, which would give me now minus 25 over 16. And then all we'd have now is the minus 6, and that would be equal to 0. We could take this over to the other side, and what we'd have now, if I put this into 16, so what am I going to have? What's that going to give me now? Minus, let's have a think, what's that's going to be? That's going to be minus 96 over 16. Thinking about it, this is going to get a little messy, but we'll do it anyway. X plus 5 over 4 all squared is going to be equal to, so that's going to be 96 over 16, so 96 over 16, and then we're going to have plus 25 over 16. If I add those two together, what's that going to give me? That's going to give me 121, so x plus 5 over 4 all squared is going to be equal to 121 over 16. If we now square root both sides, and this really is a mess, isn't it? X plus 5 over 4 will be equal to plus or minus the square root of 121 over 16, which is going to be 11 over 4. And then we'd simply subtract the 5 over 4, so x would be equal to minus 5 over 4 plus or minus 11 over 4, which are going to give us exactly the solutions that we had before. That's hugely messy. You may even want to just complete the square on this part and leave the 6 over the other side. But you can see by adding 11 over 4 to this, we're going to end up with the solution that we've got up here. And then if we subtract it, we'll end up with the other. So there we go. That's nice and, well, I say nice and straightforward, fairly logical, that x is going to be equal to minus 4 or x is going to be equal to 3 over 2. And I'll let you go at that one. Okay, let's move on, because that's deviating away a little from where I really wanted to go. As you can see, completing the square can get a little messy. Okay, let's look at this one. This time we've got a simultaneous equation, or simultaneous equations. What we need to do in order to solve these is either make the x's the same or the y's the same. Once we've done that, we consider the sign in front of that term. So with this one here, I've got 2x plus y, so let's write it here. 2x plus y is going to be equal to 7. And then I've got 3x plus 3y is equal to 15. Now with this one, I've got two choices. I'm going to make the y's the same. I can either multiply all of this one by 3. If I did that, what I'd end up with now is 6x plus 3y is equal to 21. And then the other equation below would be 3x plus 3y is equal to 15. That could be a choice. Alternatively, I could just divide all of this by 3. So my equations would be 2x plus y is equal to 7. And then we'd have x plus y is equal to 5. All I've done is divided it to make the y's the same. The general practice is that we call these equations 1 and 2. The number that I've made the same, if the signs in front of them are the same, we subtract downwards. If they are different, we add. So we're going to subtract downwards. So 2x minus x will simply give me x. Y minus y is going to give me nothing. And then 7 minus 5 is going to give me 2. So we can see x is 2. All we do to find y is sub it back in. So if x is 2, we can say 2 plus y is equal to 5. And we can see that y is going to be equal to 3. So basic linear simultaneous equation, and our solutions are x is 2 and y is 3. If we had done it this way, you can see what we'll end up with now, subtracting down, is 3x is going to be equal to 6. So x would be equal to 2, and we would go straight back through. What we'd have now is 3 lots of 2, which is going to give us 6, plus 3y is equal to 15. So what we'd have is 6 plus 3y is equal to 15. 3y subtracting 6 on both sides is 9, and y is going to be equal to 3. So you can see we get the same ones now, exactly the same way. It's just this way is slightly easier. We could have made the x's the same. If you wanted to, at this stage, you could have said, I'm going to make the x's the same. And what we would have done is change these into 6's. So we would have multiplied all of this one by 3 and all of this one by 2. Just be careful. Remember, if the sign in front of the one that you've changed is different, you're going to add them. If they are the same, you subtract them. You find one value by eliminating, this is called elimination, and then you sub back in. Okay, let's go for another one. Another quadratic. So nice straightforward quadratic. Ax squared plus bx plus c, it's in the correct order. This one looks like it's going to factor. Two numbers to give us minus 12, for add to give minus 1. That's going to give me x plus 3, and then we're going to have x minus 4. They're two numbers multiplied to give minus 12 and add to give minus 1. So x would be equal to minus 3, or x would be equal to positive 4. Okay, let's look at this one right here. What we've got now is the following. We've got 3, the quantity 1 minus x is equal to minus 4 plus 4x. With this, you can be a bit cheeky with this one. I'm not going to do it. You could factor this now. Unless we can divide through by a common factor. So for example, if this was 4, I'd just divide the whole equation by 4. If not, we just expand the bracket out. Be careful when you're expanding the bracket. 3 times by 1 is 3. 3 times by minus x is going to give us minus 3x is equal to minus 4 plus 4x. As stated, you probably can see that that can factor, and we can actually cancel off if we get a bit cheeky, but we'll leave that as it is. So with this one, I want to get numbers on one side, so I'm going to add 4 to both sides. Remember, don't say subtract. This is my pet hate. When people say take 4 off both sides, quite clearly taking 4 off both sides is not going to work. We add 4 to both sides. So 7 minus 3x is equal to 4x. we simply add the 3x to both sides. Don't say subtract it, it does my head in, really does. 7x, so 7 is equal to 7x, dividing both sides by 7, we can see that x is going to be equal to 1. So nice straightforward thing. If you wanted it here, you could factor out minus 4. If you wanted to, that's an option. If you factor out minus 4, you'll see what happens with that one, but I'll leave that one for you to think about. Okay, next one, 5x is equal to 3x. Well, this one simply can't work, okay, other than for 0. There's no number that 5 lots of is the same as 3 lots of. So quite clearly on that one, x is going to be equal to 0. Right, this one here, x squared minus 6 is equal to 0. It's not a difference of squares. So all we're going to do is add the 6 to both sides. So x squared is going to be equal to 6. Solving, we square root both sides. X will be equal to plus or minus the square root of 6. This is what we call an exact solution. A third form, which is this right here, is an exact solution. So if you wanted to find what that was in terms of a decimal, root 6, 2.4, and so on and so forth. So remember, you're going to have a plus or minus. If you drew this graph, what we'd have now, x squared minus 6 will look something like so. We'd have one solution here, and we'd have one solution here. Here is minus root 6, and here is plus root 6. Because if we square both of those, we're going to end up with the value now of 6. Just be careful, okay? X squared is equal to 6. X is going to be plus or minus root 6. Okay, this one here. We got 4x squared minus 6x minus 9. We might want to try and factor that one. You're more than welcome to have a go at factoring it. I've got a feeling it will factor. If not, we can just use a quadratic equation. So quadratic equation, remember, x will be equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's get our values here. The a term, this is in the correct form, ax squared plus bx plus c. Do check. If these are interchanged, make sure you have it in the form ax squared plus bx plus c is equal to 0. So the a term is going to be equal to 4, the b term is going to be equal to minus 6, and then the c term is going to be equal to minus 9. I keep looking at it thinking it should factor, and I can't quite, whilst I'm talking, get my head around what it's going to be. But we can do it as a quadratic equation. So what we'll have then is minus b, so we'll get minus, and it's going to be minus minus 6. Be careful with this. Remember, b is minus 6. Plus or minus the square root of b squared. Now I'm just going to put in here 36. Minus 6 squared is 36. Minus 4 times by a, which is 4, times by c, which is minus 9. Kill a mistake, don't just put 9 in. Divided by 2a, which is 2 times 4, which is going to give me 8. So our first solution is going to be 3 plus 3 root 5 over 4, so it didn't factor, which is going to be now x is equal to 2.43, and I've done that to 2 decimal places. So 2.43, and then to get our negative value, all we'll do is swap that over, and then that will give us now the other one, which is minus 0.93. I'll do that to 2 decimal places. So x would be equal to minus 0.93. I still don't know why I want it to factor. It looks tempting, but I don't, as you can see, I don't think it's, well, it's not going to give them those solutions. Okay, let's see. I think I've put a couple more on here. The only thing we're really missing is really nasty algebraic fractions. But if you do get those, then I've done a video on those as well, and you can check those. Okay, this one, this is an expression, so all we can do is factor it. Common factor of x, and that's going to leave me now 3 minus x. So for example, if you were to solve this, if it was an equation, i.e. it was set to 0, for example, we'd set it to 0, either x is equal to 0 or 3 minus x is equal to 0. So x would be equal to 0 or x would be equal to 3. Don't put minus 3 in there. Okay, this one, another quadratic. This will factor. Well, it looks like it's going to factor. 2 times by minus 10 is going to give me minus 20. I need 2 numbers to add to give 1, and they're going to be plus 5 and minus 4. So I can write 2x, and this is a long form, plus 5, and then 2x minus 4 is equal to 0. All I've done is multiplied, and this is mathematically dodgy. It works though. 2 times by minus 10 is minus 20, so we need two numbers that give minus 20 when multiplied and give 1 when added. That is going to be now plus 5 and minus 4. Add 5 and minus 4, you get 1. Multiply them, you get minus 20. So just tidying this up a little, 2x plus 5, and then we'll have now x minus 2. Okay, all I've done is taken the common factor of 2 out of here. Okay, and that's equal to 0. So dividing both sides by 2, that can disappear. So 2x plus 5 is equal to 0. Be careful, x will be equal to minus 5 over 2. Or x minus 2 is equal to 0, x will be equal to 2. Just consider this now, 2x plus 5 is equal to 0. 2x is equal to minus 5, and x is equal to minus 5 over 2. Okay, again, this one, it's already factored for us. It's a quadratic equation. Either x is equal to 0 or 3x minus 1 is equal to 0. So we'd have x is 0 or x is 1/3. Right, complete the square. We've done enough of these, so it would simply be a case of now x minus half the coefficient, which is x minus 2. Then we would square it. We would subtract away this number squared, which is minus 4, and then add the original 6. So it would become x minus 2 all squared, and then we'd have plus 2. If that was an equation, you wouldn't be able to go on and solve it and find real roots. That's beyond the syllabus, so all you'd be asked to do is complete the square. Okay, another simultaneous equation. This one right here, what we've got is the following. 3x minus y is equal to minus 2, and x plus 2y is equal to 11. So this time, we've got the choice. In fact, we've got lots of choices. And I'm going to do this a couple of different ways. The first way is using elimination. And I conceive I can either make my x's the same or make my y's the same. I'm going to make my y's the same, and I'm going to call this one equation 1 and multiply that by 2. That's going to give me 6x minus 2y is equal to minus 4. Now the bottom one is going to be x plus 2y is equal to 11. I call this one equation 1, I call this one equation 2. I've now made the y's the same, and the sign between them is different. If I add it, it will eliminate these. So adding the equations, we're going to end up with 6x plus x is 7x. These two will disappear, and we will end up now with 11 minus 4, which is going to give me 7. So x is going to be equal to 1, simply by dividing both sides by 7. If x is equal to 1, what we can do is sub that in to equation 2. 1 plus 2y is equal to 11. Subtract 1 from both sides. 2y is equal to 10. Quite clearly dividing both sides by the 2, y is equal to 5. If you want to sub it in the first equation, you could do it slightly more messy though, and I would try and avoid that. But that works. An alternative for this one now is to use something called substitution. So if we take equation 1 could be rearranged as 3x plus 2 is equal to y. All I've done is added 2 to both sides and added y. What we would now do is simply sub this into equation 2, and that by doing that we would eliminate now the y's. So equation 2, I've got x plus 2y. Now as soon as I see y, I can put this in right here, and that's going to give me 3x plus 2, and that will now be equal to 11. So expanding this out, I'm going to have x plus, now this is going to give me 6x. So I've got x plus 6x plus 4 is equal to 11. So collecting up, 7x, subtracting 4 from both sides is equal to 7. X is equal to 1. And then of course all we need to do to find y is put it back into this one. And we can say 3 lots of 1. No, don't want that. Plus 2, that's what I want, is equal to y. 3 plus 2, 5 is equal to y. And that is called solving a simultaneous equation by substitution. So your way, I'm kind of running out of steam a little. Hopefully they've been of use. That one looks like it's going to factor as well. I'll let you have a go at that one if you want. That will factor. 3 times by, is it going to factor? No, it's not going to factor. My apologies. You're going to have to use the quadratic equation on that. I'm kind of, as I say, I'm running out of speed a bit. So I'll leave that one to you. Don't know why on earth I thought it'd factor. It's not going to. There, basically, that's, well, 40 minutes now of looking at loads of different things that could pop up at GCSE level in terms of your algebra. I think the only thing that we're missing are the equations, simultaneous equations, where we've got one linear and one non-linear, which I've done on my site, and also when we've got algebraic fractions. The rest of it, though, should be fairly straightforward. And I've done that as I've gone, so I'm assuming all my answers are good. If not, please do put a message at the bottom of the video.